Alrighty, so let's see. So this is going to be your physics 102, chapter 25, which is going to be the reflection of light. And like that, let me just rewrite it now. Specific mirrors. So let's go ahead and start. I uploaded a video in the module. So let's go ahead and start the first video. All right. So in this video, let's say he got a plane of mirror. So let's say we got a very smooth surface. So that's your smooth surface, like a mirror, for instance. Now, your light coming in, we're gonna call that your incident ray. So this light is gonna get hit and it's gonna come out. Actually, we get a blue for that one. At the same angle that it came in. So we're gonna call that's your reflected light ray. And let's just use this one. So because they're coming in and coming out in the same angle, this angle over here is gonna equal to this angle over here. Now this angle, we're gonna call it theta I, which is gonna be your angle of incidence. And this angle over here, we're gonna be calling that theta R, which is your, you guessed it, angle of reflection. So every time you're gonna have a ray light that has a smooth surface, this light is gonna reflect on the same angle, theta I, theta R. So let's actually write this down. So your theta I, that's your angle of incident. Your theta R, that's your angle of reflection. That's why, let's say, if, let me make this over here, make this bigger. So let's say you go in and, I don't know, let's say this is the ground over here, and let's say you have a mountain. Let's say you have a mountain and you got a puddle of water. Let's say water. Let's say this is, you got your sun right over here shining a light that goes on there. So what's happening? So the white light passes, and this white light, and actually let me go to reflection with a different color. Let's say you're standing right over here. So let's say you are standing right over here, and here is your eye, and you're actually looking at this way. So from what we talked about, the incident light is going to hit the mountain. This light is going to reflect from the water towards you with a reflection that's going to equal. So let's say this is your theta r, and let's say this is your theta I. Now, and as a result, for each one, let me actually get a different color. Let's see this color over here. Same thing, let's say you get on this side. Actually, let me get the reflection of the mountain first. So let's say we get the reflection of the mountain. Yeah, I tried to make it. Let's say that's the reflection of the mountain. So let's say you're looking at the top peak right now. So again, let's just stick with, let's just do a different color actually. So let's say you get a light ray that hits from the sun, the light ray that's gonna go down and reflect. Let's say this is the top right over here. This top is gonna reflect towards you, and so forth with the same angle. So this is gonna be your theta I, it's gonna be your theta R. Now, but why are you not seeing the reflection of the mountain on top of the clouds? And that's where you actually talk about diffuse reflection. So this is actually called your specular reflection. So let me just put this over here. Specular. And that's exactly why you're seeing a picture of the mountain on the surface of the water. But why are you not seeing a picture of the mountain on the sky when it's actually the sun is hitting it? So you got clouds over here, but you're not seeing a picture of that. That's when you actually talk about diffuse reflection. So let's say this is our mountain that we have. When the light rays are hitting it, they are not going out at the same angle. They're going in a different angle. So let's say over here, this one's going this way. You get one over here. It's going this way, and etc. Get this one over here. This goes this way. So they're all different angles. That's why you don't see. Actually, write this down. That's why you don't see this guy at the mountain, because of the diffuse reflection. Now, what about a mirror? So let's actually look at this video for a second. So, Now, when we talked about images, when we talk about diffuse reflection, that's when you have a unsmooth surface. So let's go ahead. So this is going to be your unsmooth surface. Now, when we talk about mirrors, we're talking about specular reflection because it has a smooth surface. And we talked about specular reflection, so let's say again, and this is your side mirror, and you have an incident ray coming in and a ray coming out, where you got, again, so this is your theta I, this is your theta R, your angle of incident and angle of reflection. That means these two angles right over here means they are equal. So let's say you have, let's say we take a look at our mirror. Let's say this is our mirror over here. And let's say you have a book of some sort. So let's say your physics book is over here. B-O-O-K. And let's say you're standing right over here. And this is your eye. You're looking at the book. So let's say you got a light source. So what's actually happening? So according to our little spectral diffraction, let's say from this point, the light hits this one at some point on the mirror. Now that light is actually reflected at the same angle that's going in. But what's going on in the mirror, if you actually look, you actually extend the line almost the same amount that you have over here. So let's say this is actually the same amount. And let's say it goes in to this point. Let's say the light from the bottom, this is right over here, comes back. Let's say it goes in here. So that would make it where I'm just gonna draw the little book. And what keeps on going, you're still gonna get a light. Let's say let's do a third one. Let me actually get a different color. So let's say from this corner right now, this one, actually this one's supposed to be in a different corner. So let me actually fix this. Yeah, and let's say we have let's say do the other corner going in. That's going towards our eye. And that's extended. And that's what we call your virtual image. You see, the image seems like it's there, but it's not. If you actually look at the mirror is not going to have all the spacing behind it. It's actually really thin. It's probably like, just a little thin mirror, but it seems like there's an object way far behind it. And that's when you actually talk about a virtual image. So a virtual image is an image that looks like it's coming from someplace, but it's not. So that's what your image that looks like is coming from someplace. But it's not. It is reflected. of a surface. Period. So it's an image that looks like it's coming from someplace, but it's not. It is reflected of a surface. And that's what you're talking about mirrors. Now let's say we take this mirror and let's say we find something called a concave and a convex mirror. So a concave mirror is just as like its name. It looks like a cave. So let's say this is our concave mirror, and this is your connection to the different color for the principal axes. Let's say this is your principal axis. So what's happening with a concave mirror? Well, if you have an object, let's say you have an object, this object is too big, let's make it smaller. So what's going on? You got a light that actually reflects on there that goes back. And you got a light that reflects at a certain point. So each time you're gonna have a light is gonna get reflected at the same point. Well, that light might actually also get reflected going back in that way. So this point over here, that's what you call your focus. So F, that's your focus. Now, so let's say this is your image, and let's say this is your center of curvature, C. So you see that's your center of curvature. You're gonna have an image that lines up where the focus would be. So extend this one over here. So you got an inverted image right down. Now this inverted image, that's called your real image. And you can actually project that on a screen. So a real image is an image that is projectable. Now we're going to be talking about concave mirrors in a bit, in just a second. Now, the other type of mirror that I would like to introduce is called your convex mirror. Your convex mirror, I'm going to show this down. Let me get a new one, new page. So here's your mirror over here. So when you get the light that hits an object, let's say this is your principal axis, and you got a object. So this object, you're gonna have a light that's gonna hit the convex mirror and it's gonna reflect out, or it's gonna go in, reflect in. Now, extend that, kind of like what we just did with the mirrors a while ago, and you extend this, and that's where your image will appear. So right at this point, where it's extended, that's going to be your focus. And this is going to be your center of curvature. Now, adding them both up, you will get your sphere. So let me actually go to your spherical mirrors. So let's say this is your spherical mirror, and what do you got? You got this principal axis. And let's say this is your center of curvature, C, that we define. And let's say we define that the focus is right over here. Now, the distance from the end to the center of curvature, we call that R, which is going to be your radius of curvature. Now your distance from the focus to the end, that's called your focal length. And we're going to give that a small f. And the focal length, let me just define that as how far the rays of light are focused. So the focal length is how far are the rays of the light are focused from the mirror. Which is going to equal to 1/2 of your radius. So your focal length equals 1/2 R. And again, R is the curvature, the radius of the curvature. So let's take a look at the concave mirror for a second. Now, so let's say this is our concave mirror. This is your principal axis, and you got an object right over here. Let's just make not to make it too high. So what is going on with that object? So you're going to have a light ray that actually hits it, that actually reflects down through your focus, or it goes in through the focus that reflects back. And again, that's where your inverted image is actually happening. So in this case, it's right over here. That's not a very good accurate picture, but it's be right over here now. So that's your focus. And this is both of these. Actually, let me do a different color for both. Just the ray, just a little bit. That's better. That way we can actually see the image better. So this is the inverted image right over here. Let me put an arrow to show where the light is going. All right. And let's just call this your F. That's your focus. Now, I know it doesn't look like it on the picture, but your focal length which is this and this, is going to be equal. So those are your focal length. And again, which equals to 1/2 r, which is your radius of your curvature. Now looking at it, let me actually draw a better picture. So let's say this is it again. That's your principal axis. You got, actually just make this a little bit bigger. So let's say this. So we have an image. Now, the height of the image, we can call that h naught. Let's write that over here. Object height. We're gonna call that h naught. So we're gonna get an incident ray that goes in through the center of the concave mirror, comes out with the same angle. So basically this angle is gonna equal to this angle. And you got a light ray that's gonna go through the focus. So let's just say this one, this focus is right over here. This way, so this is your focus right now. Now, yeah, that way I can just have it a little bit further. So this is your focus, and then we got an image right over here. That image is gonna have something called HI. So HI, that's your image height. And obviously that's your image right over here. Now your distance right now over here, let me actually get a different color, let me get orange. This orange distance is gonna be your F, which is your focal length. Now, the distance of the image is a way we're gonna call that your DO, which is your object's distance. And let's say this is the distance. Let me get a different color. Let me actually get yellow. The distance that the image is at is going to be DI, which is your image distance. So you get your image distance, your object distance, your height image, and your object image. And you get both of the angles in. Now, if you actually, and we're not going to go a lot in the trade into this, I'm going to actually make it simple, but if you actually look at tan theta, which is going to be your opposite over your adjacent, that's going to equal to your HI over DI, which is going to be your H naught over D naught. Taking this one, rearranging it, what you're going to have? You're going to have the height of the image over the height of the object equals minus the distance of the image over distance of the object. Now, this is called your magnification equation. And from this one, you can say that the height of the object image is going to equal to the height of the object multiplied by di over d naught. Now, there is a negative sign. Now, this negative sign, all it does, if you get it, it tells you if the image is inverted. Now, going back to our main equation, your tan theta, which is again your opposite over your adjacent. Now, you're organizing this. What you're gonna have? Your height of the image divided by the height of the object, which is gonna be the distance of the object minus your focus, is gonna equal to hi, your image height, divided by your focal length. Not focus, focal length, I mean. Now, from these, what you're gonna have? You're gonna have the image, it's the object height divided by the image height is gonna equal to d naught minus f, or do for the object minus the focal length divided by your focal length. That means your ho over hi is equal to d naught over f minus f over f. So the distance of the object divided by the focal length minus, you get f, so we just put focal length over focal length. And again, this is going to equal to your distance of the object over your distance of the image. So this one's going to equal to your d the object over f minus 1, which is, again, is going to be distance of the object divided by your distance of the image. That means, solving for this one, what you're going to have? You're going to have 1 over f minus 1 over the object is going to equal to 1 over the object. And that is what we call the mirror equation. And actually, you can actually reorganize it to 1 over f equals 1 over your focal length divided by 1 over your distance of the object plus 1 over your distance of the image. Again, focal length, object, distance, image, distance. Now, we usually solve for the image distance. Now, your focal length is positive when it's concave, and that's what we're talking about. Now, if it's convex, all we have to do is make it into a negative for convex. So let's do a little example. Let's say this is our mirror right now over here. This is our principal axis. Let's say we have an object. this object is at 3 centimeters. And it is in a distance of 12 centimeters from, actually, let me just get a different color for that one. Centimeters from this one. And your inverted image, let's say it's right over here somewhere, and it's a 1.5 centimeters half. Let's say this is your focus. Focus right now with a focal length of 4 centimeters going in. So this is your image. Let me just go ahead and put this down. And of course, the light's coming in here, so this is a concave mirror. Now, if the object was in front of the mirror, that means your DI is going to be positive. If your object was, we find out that it's behind the mirror, that means your DI is going to be negative. So let's go ahead and solve this. That means our focal length is going to be 4 centimeters, and it's concave, so it's going to be positive. Your distance of the object is going to be your 12 centimeters. Now, from these two informations, 1/4 is going to equal, well, I should write down the equation first. 1/f is going to equal 1/di plus 1/d naught. That means 1/4 is going to equal to 1/12 plus 1/di. That means 1/, the distance of the image is going to equal to 1/4 minus 1/12, which, if we solve it, you should get over 12. You get 3 minus 1, should be 2/16, and 2/12. It's going to be 1/6. That means the distance of the image is going to equal to 6 centimeters. Don't forget to invert it. 6 centimeters, that means the image is going to be in front of the mirror. Your magnification which is going to equal to your HI over H naught, which is minus DI over D naught. Let me get different color. That means the height of the image is going to equal to minus H naught or HO DI over DO, which is going to be minus 3 for the height, and we got 6/12. So 6/12 is 1, so be minus 3/12 over 2. So be minus 1.5 centimeters. And again, the minus sign just means the image is inverted. And that should conclude chapter 25 for Physics 102. Let me go ahead and share. If you have any questions, email me at abunnem@uah.edu or text me at 256-348-1480. Thank you.